Hello my dear students, let us solve some examples related to Westergaard's analysis. A concentrated load of 200 kN acts at the ground surface. Find the vertical stress along the axis of the load at a point at a radial distance of 5 meter and depth of 10 meter by Boussinesq and Westergaard's formulae. Neglect the depth of the foundation. Okay, so here we have to calculate the vertical stress using both the equation, Boussinesq also, Westergaard also, at a point at a radial distance 5 meter and depth of 10 meter. Okay, so let us solve first using Boussinesq equation. So the Boussinesq equation is, you can write in two ways. One is using this IB or KB, that influence factor is also represented by IB, but I have given KB. Okay, so sigma Z is equal to Q divided by Z square into KB or IB, that is also equal to 3Q divided by 2 pi Z square into 1 plus into 1 divided by 1 plus R by Z square to the power 5 by 2. Okay, now IB, if you have the table, you can directly take the IB value based on R by Z ratio. If the table is not given, you have to calculate IB value using this equation. What is that? IB or KB, that is equal to 3 divided by 2 pi into 1 divided by 1 plus R by Z square to the power 5 by 2. So substitute the values of R and Z. So what you will get here, 3 divided by 2 pi into 1 divided by 1 plus R is equal to radial distance, that is 5 meter, and depth is equal to Z 10 meter. So 5 divided by 10 square to the power 5 by 2. So we will get IB or KB is equal to 0.2733. Okay, if you have the table, then directly you can take IB value using R by Z ratio. Okay, now we'll calculate what is vertical stress. Vertical stress is equal to KB or IB into Q divided by Z square. What is Q? Q is equal to 200. So 200 into IB, that is 0.2733, divided by Z square, that is 10 square. So we will get answer 0.55 kilonewton per meter square. This is based on Boussinesq equation. Let us solve the same problem using Westergaard's theory. So Westergaard's formula, what it says, sigma Z or vertical stress, that is equal to Q divided by Z square into IW or KW. Okay, so here you can use the table if you have R by Z ratio value. If the table is not there, then you have to calculate IW or KW using this equation. What is that? 1 divided by pi into 1 plus 2 into R divided by Z square to the power 3 by 2. Substitute R and Z values. R is equal to 5 meter, Z is 10 meter. So you'll get 0.1733. Then directly substitute in this equation. Sigma Z is equal to 200 divided by 10 square into IW or KW, that is 0.1733. So we'll get 0.346 kilonewton per meter square. So like this you can find the vertical stress using Boussinesq and Westergaard's formula. Okay, let us take one more example. A rectangular area 2 meter by 4 meter carries a uniform load of 80 kilonewton per meter square at the ground surface. Find the vertical pressures at 5 meter below the center and corner of the loaded area, solved by Westergaard's analysis. Take mu equal to 0. Similar problem, same problem I have solved using Boussinesq equation in the last class. Okay, so we'll find using Westergaard analysis and compare the answer. Okay, so here there are two questions. The first question is at the center and second question is corner of the loaded area. So for the first question, vertical pressure below the center of the loaded area. So this point we have to calculate. What we can do here, subdivide the rectangle into 4 smaller rectangles of size 1 meter by 2 meter, because this is 2 meter by 4 meter. So we'll divide into 4 rectangles, okay, because we are calculating the vertical stress at the center. Okay, so once vertical stress if you find for one rectangle, then you can multiply it by 4. That gives the vertical stress of the whole rectangle. So that's why we are dividing this rectangle into 4 sub rectangles of size 1 meter by 2 meter. So that point becomes the corner of each of the 4 rectangles. Okay, this one. Evidently, sigma z at P will be equal to 4 times of sigma z at P due to each small rectangular area. Now, for the rectangular loaded area, what is the formula? That is sigma z. Here it is given mu is equal to 0. So this is the equation, q divided by 2 pi into cot inverse of 1 divided by 2m square, square root of 1 divided by 2m square plus 1 divided by 2n square plus 1 divided by 4m square n square. Now for each subdivided rectangle, we'll consider only one rectangle of size 1 meter by 2 meter. So ratio m is equal to 1 divided by 5. Okay, that is a divided by z. What is A? A is equal to 1 and Z is equal to 5 meter. Vertical pressure at 5 meter. Okay, then N is equal to similarly B divided by Z. B is equal to 2 meter here. 2 divided by Z is 5. So we get 0.4. Now we have M and N value. M is equal to 0.2 and N is equal to 0.4. Substitute in this equation sigma z P is equal to 4 into, because we are calculating for one sub rectangle, it has to be multiplied by 4 rectangles. So 4 into 8, Q is equal to 80 divided by 2 pi into cot inverse of square root of 1 divided by 2 into m square is 0.2 square plus 1 divided by 2 into n is 0.4 square plus 1 divided by 4 into m square n square, that is nothing but m n whole square. So m is 0.2 and n is 0.4 whole square. So we get this is equal to, when you simplify this, 4 into 80 divided by 2, 320 divided by 2 is 160 divided by pi into cot inverse of, when you simplify this you get 8.0429. How you can do this? Cot inverse, that is nothing but cot is equal to inverse of tan, 1 by tan. Okay, so cot inverse of 8.0429 is, you have to calculate cot inverse of 8.0429. So one value you get. Again take the inverse of that because it is cot inverse. Okay, so then you will get 0.1237. Once if you get that, multiply by 160 divided by pi, so you get 6.3 kilonewton per meter square. This is obtained by Westergaard analysis. Same problem you have done using Boussinesq analysis also. For that using that analysis we got 10.5 kilonewton per meter square. So you can see that in this Boussinesq analysis gives a more vertical stress value compared to Westergaard analysis. Okay, so let us take the second part of this, that is vertical pressure below the corner P1 of the loaded area. Now we have to calculate here vertical stress at this point. How we can calculate? Again we use the same formula, Q divided by 2 pi into cot inverse of 1 divided by 2 square root of 1 divided by 2 m square plus 1 divided by 2 n square plus 1 divided by 4 into m square n square. Only the difference here, m value and n value. So now m is equal equal to r divided by z. R is equal to full rectangle because we are calculating the vertical stress at this point. So r is equal to 2 and z is equal to 5. Okay, similarly n is equal to b divided by z. B is equal to 4 and z is equal to 5. So we'll get 0.8. So substitute in this equation, that is sigma z p1 is equal to, here we are calculating 80. Q is equal to 80 divided by 2 pi into cot inverse of square root of 1 divided by 2 into m square is 0.4 square plus 1 divided by 2 into n square is 0.8 square plus 1 divided by 4 into m square n square. Simplify this. Again here cot inverse, you can use what I said earlier, like that, how means tan inverse of 2.519, then again you have to take the inverse of that value, so you will get 0.3779, then multiplied by 80 divided by 2 pi, so we get 4.81. Or you can use like this also, let cot inverse 2.519 is equal to theta, or cot theta is equal to 2.519. So tan theta is equal to inverse of cot, that is 1 divided by 2.519. So that is equal to 0.397. So theta is equal to tan inverse of 0.397. So we get 21.65 degrees. So have to convert into radius. So multiplied by pi divided by 180. So you will get 0.3779. Any method you can use. Either you can use this method or directly you can calculate what is tan inverse of this value. Whatever the value you get, again take the inverse of that, you get this value. Okay, then compare with the Boussinesq analysis. Boussinesq analysis we got 7.45 kilonewton per meter square. Here also we can observe that Boussinesq analysis gives the value higher than this Westergaard analysis. I hope all of you understood. Let us take one more example. A water tank is supported by a ring foundation having outer diameter of 10 meter and inner diameter of 7.5 meter. The ring foundation transmits uniform load intensity of 160 kilonewton per meter square. Compute the vertical stress induced at a depth of 4 meter below the center of the ring foundation using Boussinesq analysis and Westergaard analysis. Okay, so now this is given. A water tank is supported by a ring. Okay, here outer diameter is 10 meter and inner diameter is 7.5 meter. It transmits a load of 160 kilonewton per meter square. So first you have to calculate what is Ri, inner radius and outer radius. What is inner radius? Inner radius is 7.5 divided by 2. This distance, diameter divided by 2, that is 7.5 divided by 2 is equal to 3.75 meter. Or not, outer diameter, that is equal to 10 divided by 2. Radius is equal to 5, here to here, here to here. So that is 5 meter. Now ratio Ri divided by Z. Ri is inner radius is 3.75 divided by Z. Z is at a depth of 4 meter. So we get 0.9375. Then R naught divided by Z. What is R naught? Outer radius, that is 5 divided by 4, we get 1.25. Now we have this formula for the circular loading. Okay, using Boussinesq equation, that is sigma z is equal to q into 1 minus into 1 divided by 1 plus a divided by z square to the power 3 by 2. Substitute the values. Q is equal to 160 into 1 into 1 divided by 1 plus a divided by z, that is nothing but we are considering for inner diameter first, inner radius, that is 1.25, first outer, that is 1.25 square, minus same formula you have to apply 2 times because it is a hollow ring. So outer minus inner you have to calculate. So similarly this is related to inner ring values, that is A by Z for inner is 0.9375. So substitute in this equation, you will get the value 23.11 kilonewton per meter square. I hope all of you understood that.